Okay, so there we go. All right. So this is a slide, like I said, that is probably a lot better than going over my resume, quite honestly, in terms of talking about how I ended up here today as a guest lecturer. And I call it my no, never, knew slide. And as I mentioned, it's something that my children have seen and heard, and mentees and anybody who's in my circle of friends have heard me talk about. And the first one is never take no for an answer. I could tell you that throughout my career, certainly beginning in the beginning stages when I just gotten out of school, I heard no a lot. I have a book a binder actually of letters saying thank you very much, but no thanks, that I'd shared with my son, who's now a freshman at Berkeley. And the word no happens a lot as you start out your career. It'll happen more as you move further up the food chain. And the bigger the prize, quite frankly, the more often you're going to hear no. And so what I tell people is, ask why. You never know. I mean, in one instance, it was kind of interesting. I asked for a job, and this was very early in my career, for a job, and it turned out it was a no. And then when I asked why, it turned out that the person who does the hiring wasn't available until a few days later. And I just came back and met with that person a few days later, and I got the job. So in that particular instance, I mean, it's a really simple one, but it showed that had I not asked that follow-up question, had I not inquired as to what the no really meant, it wasn't personal. It was just they weren't able to do it at that particular time. So it happens, many, many times throughout my career. I could tell you that now that I'm a little further up the food chain, I hear it probably more often now than ever. And just for the students listening on, you're never going to fit the exact mold. There's always going to be something about you that may not fit exactly right. And I can tell you that, moving into the corporate world, they weren't looking for a Filipino Mexican with a bad haircut. And here's a 6-figure salary. And then lo and behold, there I was. That just doesn't happen. And so, being persistent, looking for ways to navigate around. When I started with the corporate banking group at Fuji Bank, same thing. They said, well, we typically don't hire somebody who doesn't have an MBA. And at that time I didn't. And I, managed to navigate around that. So the word no is pretty common as you move up the food chain. And like I said, the bigger the prize, the more often you're likely to hear the word no. Never negotiate against yourself. This is something, happens repeatedly, especially with my kids. I'll hear a lot of times, well, I don't know if I've got the right qualifications. I don't know if they'll like me. It does say that they need somebody like X and I'm more like a Y. If you don't ask, you don't get. I could tell you in this world, you just never know. You might be exactly what they need, or quite frankly, you might be exactly what they didn't realize that they needed. So the thing that makes my hair fry is whenever I hear somebody already deciding that they're not capable or qualified to get a particular job. So never, I mean, please, if you don't listen to the rest of the lecture, please remember these 3 things. Never negotiate against yourself. Give yourself a chance, especially, and I'll share a personal story. I often heard in my community, a lot of kids were capable of going to a Harvard or a Yale or, Stanford, some of these bigger, really fabulous schools, a UC Davis. And a lot of times the kids from my neighborhood, I came from a neighborhood with some families that didn't have a lot of money and had never attended college. There's a lot of kids in my neighborhood who were first timers going to college, and their parents would talk them out of it and tell them, maybe that's not the place for you. And I knew kids who were a lot brighter and a lot more capable than me, who negotiated themselves out of a dream opportunity. And I would hate for that to happen to any of you who are listening, any of your students. So please, I'm admonishing you, don't negotiate against yourself. Take a swing. You never know where it might lead you. And then the last one is try something new every day. It sounds weird. I do it, I practice it, and my children, I torture them with this one because you'll see people a lot of times saying, oh gosh, I don't want to do that. Venturing out of your comfort zone is not easy. But I could tell you that it's made all the difference in the world in my life in terms of being able to take myself. I went to a small Catholic school with 400 boys. It was an all boys Catholic school in East LA. And, really, if I look at my career and look back, gosh, it's amazing how far I've come, but I came a lot further because of the fact that I adopted this philosophy, and it wasn't something that I did organically. I had a boss from a Japanese bank. In my first corporate banking job, I worked for a bank that doesn't exist anymore. It's now I think it's called Mizuho Bank or something, but it's a merger between Sumitomo Fuji Bank and Daiichi Kangyo. But I worked for Fuji at the time. It was the third largest bank in the world. And my boss was a Japanese native. He had been educated here, gotten his MBA here. And we used to go to dinner together. And I'd never had sushi in my life. I was 24 years old. I'd never had sushi. And he would take me to his favorite sushi restaurants. And it was just torture, I could tell you. It was really torture. And at the end of the meal, after I had turned down half the meal, things were moving. I just couldn't deal. He told me that I had such a closed mind and that I would miss out on so many things, whether it's food or music or travel, if I maintained that philosophy. And he told me from now on, including golf, that was the big thing that really made him crazy, is that I'd never played golf and I had no desire to play golf. So he told me from now on, as long as you work for me, I want you to try something new every day. And I could tell you that not only did I have a really rich experience working for the bank, but it really opened up my horizons. I tried things, and sometimes I didn't like them, but food and music and water. My wife is a Korean native. I mean, just so many things changed in my life as a consequence of having this philosophy. And so now, when someone says, "Have you ever tried that?" and if it is something new, my immediate answer is no, I haven't, but I'm ready to. And it really, I could tell you that it'll change your life. If you don't listen to the rest of the presentation, please remember these no never news, and happy to talk about them more. But at any rate, let's get into the presentation. Some of this is going to seem somewhat basic, but I really, especially for the students who are going to be in the case study later, I want everybody to have the same understanding, the basic understanding of how power works. So these are the basic components of any power, well, at least the vertically integrated utilities of the past. There's one left here in California. My former employer, the Department of Water and Power, is still a vertically integrated utility. It has the generation, transmission, and distribution. So as you can see, you've got your power plants of whatever type out in, these are utility scale power plants are usually pretty good size. There's economies of scale, which is why they built them that way. For the Department of Water and Power, they have not only fuel diversity in terms of having a variety of different kind of plants, but they also have geographic diversity. And that was intentional because of the fact that we live in a seismic area here. They knew that earthquakes and floods and now, fires that we've been experiencing lately, it was really important to be able to access power from different locations in the event of a failure. So those big towers, people, when you drive out in some communities, they have these, but more often than not, these giant steel towers are out in the rural areas or nearer to the power sources. These transmit the bulk power from the power plants to the local distribution hubs. You'll have receiving stations that will then take that power and reduce it down to where it can be moved to distribution stations and then on to the end users, both industrial, commercial, industrial, and of course, residential customers. This slide just shows the layering of power. This is how power typically flows into the system and supports demand. So if you look at the lower part of this slide here, you'll see the yellow, blue, and light blue, and the green. Those are typically your resources that are nuclear, large hydro if you have them, coal-fired plants, things of that nature, and maybe geothermal if you've got access to geothermal. It's a great baseload resource. The challenges with geothermal is it's geographically constrained. They can't build them everywhere. We have some in the geysers in Salton Sea here in California. And if you look at places like Iceland, they're built on a volcano, and they have, from what I gather, all of their power coming from geothermal. But at any rate, these are units that run, north of 80% of the time. They typically, once you pay the debt off, can be very inexpensive resources. Each of them have pluses and minuses. Obviously, here in California, we're going to be transitioning off of coal in probably 2025. Nuclear has, some obvious challenges, but we do have some nukes left here that are feeding our load. But it's, those are two very cheap resources. And of course, we have some geothermal, as I mentioned. Now, the striped ones above that are two types of, typically in California, these are gas units. So the one in red, I would say, is probably your combined cycle units that can be cycled a little bit, but as you can see, it's running all the time. It just kind of adjusts a little bit. And then the blue one above that would be your peaker gas units. And again, there's an adjustment that you could see, the flexing inward that you could see. And that yellow section above it, those are your intermittent sources, and typically that is solar. So I thought I'd show some real-time activities rather than making this a really theoretical presentation. And I encourage, having children, like I said, teenagers, they're constantly Googling everything I say, and I encourage everyone to do the same. So what I'm going to do today is share with you actual empirical data from CalISO, which is the system operator here in California. They're one of the two balancing groups here. We have CalISO, and then the Department of Water and Power is its own balancing unit there with about 25% of the transmission in California under its own control. But the vast majority of transmission is handled by CalISO. And they produce data, and you can Google it, find this slide. If you look on this day, this slide, it's October 17, 2020. You can see this actual slide that they produce themselves. So this is a day when, and I want to share one last thing. You're going to hear a bit of a view today. I'm not an environmentalist, but I live on this planet with everybody else, and I do work for the gas company. I worked in the power industry virtually my entire career. So this is going to be a view. So I'm going to be honest about that I have a particular view, but I'm going to try to the extent possible to be 100% honest with every single thing I share with you from now until the end of our presentation. So this is going to be empirically supportable data. Like I said, you can Google it, but I want folks to have comfort that I'm not just making things up, in order to support my argument. I'm just trying to share information, and mostly so that the students with whom I'm going to be talking about the case study later will have a basis of understanding, and it will help enrich that experience later on this afternoon or this morning. So again, this is a day that there was a sudden power loss. And if you look on the orange there, that is gas-fired power that came in. And if you look, there's a little, I don't know if you could see my cursor, but there's this little bend here that's happening, right? And that was a wind that just decided it wasn't going to blow for a period of time. It was a fairly good chunk. It was 3,000 megawatts. This here in the middle is our friend solar that was running, and solar wasn't able to offset it. So CalISO was forced to bring online some gas units in order to offset that. So the reason I showed this slide is there is a relationship between all renewables, intermittent power, and natural gas. Until someday when they come up with something like it, that ability to instantaneously respond to loss of power from other sources, natural gas is the most natural way in which to offset those sudden losses of intermittent power. But okay, this slide is not as scary as you think. So what I did here was I looked back over the last 9 months. As some of you may recall or be aware, we had a couple of heat storms this summer where there was a significant loss of power. We had units that in the summertime typically go offline for service. Sometimes they go offline because of system failure. But at any rate, the summer had some major challenges. We had, again, very hot days. And what I did was I looked back at the CalISO data, and I looked on the hottest days for every day over the last 9 months. So I just modeled this just to see what it looked like. And you can see here that the orange portion is gas. The gray one above that is imported power, and typically when we import power, it's coal and gas. So those two combined, you could see they made up all the way back to January up to September. And I stopped at September because typically that's the hottest month. Both August and September from a utility standpoint tend to be the hottest months of the year. So I thought that was a reasonable stopping point. But at any rate, so this shows the 9 months, and you can see that the mule pulling the train for most of the summertime, or for most of the year, quite frankly, and especially in the summer, is coal-fired power, which produced, I'll see right here, about 54% on average for the 9 months, and then almost 70% for just the summer months of July, August, and September. So in this one, I started looking at the evening load, because one of the challenges with renewables, and having worked at the department, I think Department of Water and Power has, if not the most, certainly among the most renewable energy, and solar in particular, have been really aggressive with the feed-in tariffs and different programs to encourage the use and proliferation of solar throughout their service territory, which is really a laudable thing, and in my tip of the cap to my brothers and sisters over at Water and Power. But at any rate, one of the challenges, obviously, with solar is the fact that it doesn't work too well at night. We've had some issues with wildfires. In Texas, you saw there were some issues with snow. So there are different things that could take solar offline. And again, what the thing that complements it best is solar power, or rather gas-fired generation. It's a complement both on the front end as solar starts to ramp up, and on the back end as it starts to ramp back down. But what I did is I wanted to see what happens at night, what happened every night on the hottest day over the last 9 months at 6 p.m. And again, so 6 p.m., summertime, there's still a little bit of sunlight. I think there's enough radiance for us to produce. And you can see again, there's quite a lot of orange and gray, and particularly a big chunk starting in June, July, and August. And you could see again, for 9 months, there was about 63% of the power came from imports and gas, and it ramped up to about 66%. And again, I did the same thing at 9 p.m., hottest day, hottest hour over the last 9 months at 9 p.m. And as expected, now it's probably dark everywhere in California. And so the CalISO showed that it now is for gas and for gas and imports, it went up to 73%. And through the summer months, obviously, it's going to go even higher. It's almost at 75%. So you can see that contribution of gas and imports had increased and increased substantially, especially in the summer periods. So at midnight, as you'd expect, not a lot of sunlight. So we don't have a whole lot of solar, and there's some wind there, which is great. And batteries, I don't think made much of a contribution at that time. And again, a lot of solar, or rather gas. And what I thought was notable about this is there's a lot more imports. And typically what happens in California, and this is something that the Department of Water and Power used to take advantage of, at night, there's a lot of units that are running, both in state and out of state. There's a thing called the N-1 condition that you have to have a certain amount of contingency available, usually your largest unit that could trip or go offline. You have to maintain that as a contingency. So pretty much every utility has to maintain this cushion, this extra capacity availability. And so those units will run at a very low level. They typically don't like to shut them completely off. So there's always something available in terms of electrons that are just flowing and available. And some money's better than zero. So they'll dump that power. All the utilities have this surplus energy floating around, and they'll typically sell it at a substantial discount, or even give it away free sometimes. So this increase in imports is not surprising. It's probably a lot of very cheap power on the margin, like I said, virtually free power that you can take. And DWP used to use it to pump water up on its Cascade pump storage facility, which is about a 1,250 megawatt pump storage facility. It's really a black start unit that they use, but in order to pump the water up, they have to use the cheapest power available, and they typically use this gray section to pump the water up during the day, or in the evening rather, during peak or super off peak periods, and then they would run the unit during the peak hours of the day. But that gray is not unusual, and I thought it would be interesting to share with the group. And again, you can see you're up to 72% imports in gas at midnight. And again, this is all CalISO data. I didn't manipulate it. I just gathered it. This is one of the heat storm days that I thought would be interesting to look at. And again, that slide there that you can see is from CalISO. If you look on their website, they provide this data here. It's pretty granular and it's interesting to look at. And this was the source data I used to create the slides that I just shared with you. It was a really hot day in California, and it had set records in Woodland Hills. It was over 100 degrees at night, and it was 121 degrees in Woodland Hills. Those are temperatures that really for utilities are scary because things fail. They're also scary from a public safety standpoint, because if it's 120 plus degrees outside in a small apartment where you may have some seniors or other folks who are not that ambulatory, I mean, it could be 130 or 40. It becomes a kind of a life and death situation. So you want to have your units up. You want to have availability to power, reliable power during those times when you do have these very excessive heat storms, as we like to call them. At any rate, even at night, it was very, very hot. And this was a shot at 8 o'clock, I believe, at night. And you still had 55% of the power being provided by natural gas. This was a slide showing what was happening, and that little green bump there in the middle is our friend solar. It comes up typically around 10 to 3 is your optimum solar periods. And you can see this is a snapshot of pretty much what happens every day. This is a little bit unusual on the gas side. Usually don't have that steep a ramping of gas units coming on or gas feeding into the system. But again, this is one of the hottest days of the year. And 78% of the power was coming in both from gas and imports, was coming in to serve load because it was an extraordinarily hot day. But the green part certainly is something that you'll see every day, unless it's snowing, there's smoke from wildfires, it's not cloudy, rainy. Those are all things that can kind of interfere with solar. But other than that, this is a kind of a typical load curve, how solar will serve load. I'm going to move this here. It's kind of getting in my way a little bit. That's better. This is what I like to call the solar banana. So solar makes up, like I said, a good chunk of our power in the middle of the day. We're blessed here in California to have, an abundant resource that we're tapping, and we're going to increase its contribution going forward. And this is pretty much how it looks every single day, and especially in the summertime where we get a nice contribution of solar. You can see the steepness of this, what I call the solar banana, is only going to increase. And what responds to that, the thing that responds the most effectively, at least today, is natural gas. If there's any glitches like the one you saw earlier, and we saw the loss of wind power, the same with solar can occur. I was there for a number of years, and they can track things, weather patterns, and you could see clouds coming in, and they would anticipate cloud cover coming in and taking out large swaths of some of the solar arrays that they have out in the desert, and they would prepare for that, and they would get gas units ready to step in and take over. When we had the eclipse a few years ago, that was really fun to watch. We knew it was coming, and we had units at the ready at Water and Power. And sure enough, when the solar eclipse came in, the solar went off for a bit and the units came on. Obviously, power didn't go off during the eclipse, and it was because you had dispatchable power available to offset the loss of solar during the day. But this banana is only going to get higher and steeper. That being able to instantaneously offset this power is going to be mission critical, whether it's gas, coal, nuclear, whatever it is. You've got to have dispatchable generation. So I'm going to touch on a thing that I really want the students to remember, because we're going to talk about this later, is the difference between capacity and energy. I think this is really, really critical. And I know that there's some engineers on this call. It makes me an engineer's cuckoo when they hear people talking about solar capacity. Capacity is something that is readily available, that when you press the button, it comes on. Energy is something that's produced and consumed pretty much instantaneously. There's a big difference between solar, wind, and other intermittent power resources, which are not instantaneously available and not readily available, like at night, for example, or when it's not windy. So there, from a utility perspective, they make a distinction. I make a distinction. I want my students to make a distinction today between a dispatchable generation, that has capacity, and energy that is produced and consumed pretty much at the same time. There's a huge difference, and I just want to make sure that people can make that distinction. And certainly my students this afternoon, I want them to be able to make that distinction. The reason there's a need for batteries is because solar does not have capacity. That the batteries are going to produce the capacity, and that's where they're going to be able to store the energy. That long duration storage is what makes other types of resources important. You saw the earlier slides where you saw that stacking of power today, and at least in my lifetime, more than likely, we're going to need that sort of a stacking. Coal is going to be going away shortly. Nuclear is going to get phased out because for obvious reasons. Natural gas is there. It's the now term solution. I'm hopeful that one of the students at UC Davis comes up with something that can replace it someday as a dispatchable, reliable, resilient resource. But for today and for the foreseeable future, the type of energy that complements this solar that's going to get steeper, this banana is going to get bigger and steeper. Right now, the near-term solution is natural gas. I'm going to go over these. I don't know, Professor, how much time we have. If you want to, I can go through a couple of slides very quickly, or if you want to take some Q&A, I can do that.
Well, we've got, I think we've got about 10 more minutes to go through slides. I want to reserve some time for questions. So we could stop here, get some questions, and then pick up again, or we could kind of go through the remainder of your slides. What do you think?
I could go really quickly. If I've got 10, I'll use 5 because I'd rather have questions, quite frankly. But yeah, we'll make sure that I wanted to really have some time to answer questions today, if that's possible. I think it'd be a lot richer experience than listening to me jabbering on. But again, wanted to share some information. This was what happened this last summer. This was documented and predicted. Pulled this right out of the Cal ISO. There was a correspondence that's available. Again, I encourage everyone on this call, and especially the students, to check my grammar here and make sure that that it's accurate and supportable. But this was an excerpt that I took out and I've shared with my executive management that predicted almost to the megawatt the amount of the deficiency that we had this last summer. The way we solved this was utilities asked customers to shed load. So everybody that was that already agrees to shed load was asked to do so this last summer, and then every unit available was asked to fire up. I know that the Department of Water and Power and other utilities that still control their own generation resources were asked to bring units on. There was a lot of units that were purchased. There was some power that was imported. But as you probably guessed, when it's hot in California, it's hot in Arizona and Nevada and other states, adjacent states. So, excess power from adjoining states is not always available. But what was interesting is the fact that they predicted it. And the scary thing is next year, they're predicting over 2,000 megawatts for the next 2 years of deficiencies. We will not be able to shed load or magically bring on new units in the next 2 years. So I know that Cal ISO and all the smarter brains that we've got up in Sacramento and throughout the state are trying to come up with a solution to this, but this is a considerable challenge, I think, and one I know they're working on. But this just shows the importance of having readily available generation. This is not going to get solved with all due respect with wind and solar. You've got to have dispatchable resources. I know that there's a big struggle right now with some of the units for the Department of Water and Power in particular to shut off and get rid of some of its in-basin units, obviously to convert its Delta, Utah facility, its 2,000 megawatt coal facility will become a combined cycle plant in 2025. But this should really be alarming to customers. I mean, the fact that they got it right this year, I'm guessing they're going to get it right next year and the following year. And shedding load is not, I think, thoughtful energy policy for a first world country or a first world state. Again, this is an interesting slide for the folks who really love batteries. The fact that in order for us to achieve just 50%, I believe this is what it says here. I'm trying to read my slide here. Yeah, in order to achieve the goals that we have here, that we'd have to bring on 8 times the amount of battery capacity there is, I think, in the entire country. And this was provided by, I think, if I recall correctly, Columbia University was doing some analysis. So I always talk about the fact that batteries have their place, and certainly they are a useful tool in terms of helping us achieve our climate objectives. But we are not going to be able to battery our way out of this. And I want to emphasize the challenges are the amount of space, resources, and the fact that it's going to put our, if there's going to be social equity, I'm guaranteeing you that we're going to be putting these, more than likely be putting these container-sized batteries in communities, underserved communities that are already carrying, in my view, more than their share of the energy burden. So I prefer that not happen. Again, this is another study from Columbia University. People have been, every day I hear that gas is going away, and it will someday. And let me just be honest, I'm hopeful that someday we'll have no fossil fuels. But for the foreseeable future, you could see that even everybody, quite honestly, Cal ISO, third-party analyses show that gas is going to be a part of the story. It's going to change. I think it'll be more leaning toward peak need. It'll be more to complement renewables, intermittent resources. As you saw that banana, as it continues to grow and probably expand height-wise, the hours of the day when the solar contributes will not change. It'll stay as long. It's certainly based on prevailing technology from 10 to 3 every day, 6 hours a day. You're going to have an abundant amount of solar, especially here in California. But you're going to have dispatchable power for the other 18 hours a day if you still like ice cream. This is just a little propaganda. This is something that our new CEO, Scott Drury, has said, and I want to make sure that everybody sees it. It's the fact that we complement and appreciate the fact that we have this role in terms of achieving our renewable objectives here in California. Electrification doesn't happen without us. Solar will not happen reliably without us, and being able to maintain power sources, reliable and low cost power throughout the day. You got to have some other resource, and we're it right now. This is just a quick slide to show you, where the emissions come from in transportation, as you expect here in California, is a big part of it. Electrification of transportation could be one of the solutions, but the electrons are only going to be as green as the molecules flowing into it, and that's where we come in. We're trying to decarbonize as quickly and cost effectively as we can, so that when you electrify your transportation fleet, that you'll be moving clean electrons instead of just kicking the can across to other states and putting, really the way we like to call it, exporting our GHGs to Nevada and Arizona. These are some of the solutions that we have. We've got renewable natural gas. We're taking organic materials and converting them into a lot lower carbon fuels. It's not fossil free, but it is addressing a big challenge that we have here in California. We have a wonderful dairy, a robust dairy industry, and we don't want them to go to Texas. And so this is a way in which they can address their methane contributions. Methane, as everybody knows on this call, is one of the worst contributors to climate effects, and this is at least a near-term solution that works really well. We have RNG in our pipes today at SoCal Gas. We're very proud of this low-tech, high contribution approach to this, and if when they build a better mousetrap, we'll be game to try it. Electrolysis, another way, for the chemistry majors out there, this is pretty old chemistry, a way in which you can convert water into hydrogen and oxygen. These are the different types of products that are coming online that use hydrogen and RNG. And we're really excited about the future. And quite frankly, I'm looking forward to the new things that students at Davis and elsewhere will be coming up with. This is our value proposition. This is the reason why SoCal Gas exists, and the importance of its role both today and in the future. I know that there's a lot of pushes all over the state here. We're one of the most progressive states in the nation, and they're talking about things like gas bans, which I'm hopeful that won't happen. But having customer choice, I think, is absolutely mission critical. We have more than one kind of candy bar in this country for a reason. Having dual fuel abilities, especially when there's wildfires, PSPS events, which we experience here in California, is kind of the new norm. And for public safety purposes, for folks who live out in rural areas. They can't store enough diesel fuel on site. And so having a natural gas backup, I know that for hospitals, Kaiser, I believe, is one of the hospitals that won't perform surgeries unless they have gas-fired backup. So just having that dual fuel capability, extremely important from a variety of perspectives, but obviously for public safety, I think it's mission critical. For customers who have gas, appliances, things and things like that, I know that we're looking at, transitioning to different kinds of appliances, heaters and whatnot. It's a great idea. Let's do it in a way that doesn't burden folks living on the margin. Let's make that transition cost effectively. I don't think we can subsidize our way out of this. Let's do it in a way that's economic for everybody, especially when 1 in 4 Californians are out of work. I'm hopeful that we make this transition in a way that doesn't, unfairly burden those communities. Resilience, one of my favorites. Last year, about most customers, electric customers, myself included, experienced between 22 and 36% outages in their service territory, whether it was because of a PSPS event, a system failure, or somebody ramming into a power pole. For gas customers, they experienced a 2% outage, 2% versus 22%, and that's because our equipment is underground. Electric utilities are being pushed to move their equipment underground. More the merrier, come on down. All of our equipment is underground. We have 100,000 miles of pipe. It is already resilient. When there are wildfires and things like that, our equipment is unscathed and we can provide electricity for pumping, for example, for firefighters who are out there still trying to fight the fires when we have these wildfires that are going to be more and more persistent in California. Water only flows one way unless it's compelled to do so. And if they don't have power, they're not able to protect property and people. And again, the biggest one for me, having been a newcomer to this company, I just joined SoCal 12 months ago, is the idea that if you don't have a freeway to move decarbonized fuels, this push for electrification is really not going to achieve the objectives, the climate objectives that people are hoping for. Those electrons are only going to be as clean as the molecules that flow through them. We own the freeways, and we at SoCal Gas don't care what color the cars are. So the greener they are, the better for us. But if you don't have that delivery mechanism, that 100,000 miles of pipe that reaches into every customer, residential, commercial, industrial customers, we won't be able to realize the full benefits of a decarbonized fuel future. So with that, I'll stop. Professor, how'd I do? Close to 10?
Yeah. Timing wise, 1 minute over. So I was really appreciate that, and I appreciate your time. Yeah. So we'll give you some virtual applause here for putting this presentation together and sharing it with us. And we've got a lot of comments in the chat with various questions and comments.
Okay, we'll pick the easy ones. I only had 1 cup today, so.
Yeah. Well, I'm going to start actually because I want to ask you to share a little bit. I mean, you talked about kind of the need for capacity, right, and dispatchable load, but you also mentioned long-term duration storage and short-term, and we've had a lot of speakers come in and talk about batteries and the role that they're ideally suited to play is that 4 hour, up to 4 hour, potentially up to 8 hour kind of window. But when we think about kind of seasonal storage, that's a little harder for batteries, especially to play a role. And you talked about kind of the relative scale, at least in the now term, in the next few years, that batteries still need some time to ramp up. But I wonder if you just talk a little bit about natural gas, kind of your vision, how you see kind of the long duration storage challenge for seasonal storage when we think about.
Okay, so let's start with batteries. So like I said, having worked at the department for, been around water and power in the city and utilities for my entire career, batteries definitely have become, the solution du jour. They definitely have a role. For 4 to 6 hours, they're terrific. We're getting, they're getting cheaper, they're becoming more efficient, but they still have limitations from the perspective of long duration storage. They're not that solution, maybe a day or two. One of the things that I always tell people when we talk about solar energy or we talk about the solar battery strategy, for the students out there, remember this statement: what happens on day 2? If the batteries get utilized on a given night because it's a hot, you have a sustained heat wave like we did this last summer. We had 2 of them that where it's, you know, in excess of 100 degrees even at night. On day 2, if you've utilized your batteries that night, the next day you will not be, in the morning when the sun comes up and your solar panels haven't been able to fire up, you've got a real problem. So batteries have their limitations in terms of being able to provide, as you pointed out, Professor, that long duration storage option. The thing that's most exciting for us at SoCalGas is hydrogen. While RNG is the near term or now term solution, the future really is hydrogen. It's something that we're exploring very vigorously. We're hoping to get state help. I think we're hitting a couple of roadblocks and stumbling blocks in terms of trying to, to get there. What I would really love, and especially with this really learned audience here, is for help, quite honestly, where we are and where we need to go. Where we are is, you saw the slides. I mean, those were slides taken from the sorts of resources we have access today. We need to transition to something greener, better for our children and children's future, and quite frankly for the world, because other countries are, rapidly industrializing. We've got 2 billion people that are itching to have big screen TVs and cell phones in China and India. If they transition and use the same playbook that we used in terms of petroleum and relying on petroleum and coal and things of that nature, without OSHA, we're going to have a way bigger problem than we have here in California. It'll be a global calamity if we don't come up with a solution here in California that's economic and helpful. The storage issue, there are tons of limitations in terms of long duration storage that can be solved with hydrogen. One of the things that hydrogen that we're looking at is the fact that you could store large quantities of it. We're looking at I keep mentioning water and power, my apologies, but they've got that power plant out there. It's a coal facility. It's going to convert in 2025 to a combined cycle gas unit. But the plan for Marty Adams, who's a GM, my former boss over there, is to convert that to a hydrogen-based facility. They have these salt caverns that are ideally suited for storage of hydrogen, of gases, and hydrogen in particular. So what the beauty of hydrogen is that you could store almost indefinitely large quantities of hydrogen, that green power that you could put underground in these caverns and elsewhere, and be able to store long duration storage in quantities and move a season's worth of power. So when you have an abundance of solar, for example, you could create hydrogen power. When you have an overabundance or a surplus like we have in California, we've experienced the last couple of years, we have with renewable curtailment, instead of dumping that power to our neighbors or paying them to take it, we could produce hydrogen, store it underground in the springtime when we have an abundance when load is low and we have an abundance of solar, and then use that stored energy in the summertime. An entire season's worth of hydrogen power. It's really a game changer, Professor. I hope I answered your question.
Yeah, thanks. I'm going to give you a slightly harder question now. Looking through some of the chats, but I think actually one of your slides pointed out that methane or natural gas is itself a climate pollutant, right? It has high GWP, and so any kind of leakage, whether even if it's renewable natural gas, if there's leakage, that can pose problems. Now, aside from Aliso Canyon, right, there is a concern that there is fugitive emissions, right, meaning kind of these smaller leaks that are difficult to, right, and that can happen. And recognizing kind of there's a now term, right, which we need kind of the gas system to. I mean, it's 70% of the load on these hottest days. There's a seasonal storage component that can't really be replaced by any other kind of source. But as we look to a decarbonized future, right, is the answer to kind of move towards hydrogen because it doesn't have those that GWP, or is it to try to figure out technologies that reduce these fugitive emissions? I mean, what does that vision start to look like? Thinking about, because when we think about SoCalGas as a company, you've got assets in the ground that have been here for, over 100 years, and
Over
then
100 years. Yeah.
right, and then looking forward, those could be there for over 100 more years. So there's a concern. What is that long-term strategy for reducing the global warming potential, right? Whether that's from emissions or from even, even still continued use, right, of these, because it's still CO2 production. If it goes well, if it's not emission, if there's not a fugitive emission, it still has that, unless there's maybe CCS, or what is that long-term vision that you see for decarbonizing? And I know you're asking us to figure it out,
right? Yes,
in some ways, but I do. But what is that vision today, if you can kind of look forward to that 2040, 2045 goal that California has?
And that's a great question, actually, and it is a question that we're looking at very seriously at SoCalGas. And the reason is what's happening right now, in terms of the pushback and the push for getting rid out of fossil fuels is an existential threat to our company. So no entity that I can think of is more laser focused on identifying a solution past 2045. Like I showed you whether it's McKinsey or Black and Beach or, Cal ISO, everybody knows that gas is still going to be around, past 2045, or at least through 2045. So that is kind of the magic milestone that we have to come up with some solution that is a workable solution that does, in fact, address these challenges. And that's where our focus is right now. We have time. We hope we have time to come up with that solution. It's going to take all of us, Professor. Quite honestly, it's not going to just be SoCalGas. To address this climate issue is going to require all of us sitting at the table and not. I know folks get paid to yell at us, but we really would love to sit down with them and say, well, we get that, but as I said earlier, here's where we are. Here's where we need to go. What's the interim solution, and how can we come up with something that won't bankrupt families? Won't put us at risk of having a third world reliability system in a power system here in California. We can't. None of us can afford that. What I'm afraid is they're gonna come up with a solution, and we're gonna have DREG Part 2 here in California, where they forgot about thinking about what happens if. So let's make a thoughtful transition to this new world, whatever it might be. With regard to your questions on fugitive emissions, that is definitely a challenge across the state. Thankfully, and again, feel free to Google me, we have the lowest emissions, other than that one situation that happened in 2015. That was an aberration. That was really unfortunate. We are really sorry that happened. But as a consequence, that is the safest, cleanest, tightest storage facility on Earth. It really is. And we went back and those lessons learned were applied at our other storage facilities. I know people are pushing to get rid of these facilities. I could tell you that gas doesn't run, as you know, Professor. It doesn't work the same as other types of, like electrons. It doesn't move instantaneously. You've got to have local storage. So unless we come up with a viable alternative that is, again, reliable, resilient, affordable, kind of checks all those key boxes, we're going to still need to have local supply. I know that for DWP in particular, if they didn't have access to that local storage at Playa del Rey, we would have had catastrophic outages throughout the Southern California. Those units came online, Scattergood, Haynes, and the other power plants that are in basin rely on that storage facility. We rely on Aliso here in California, and those units were vital this summer, as you know, as I showed earlier. That 500 megawatt shortfall would not have been offset had it not been for the fact that we have in-basin storage, that we had in-basin generation capacity, and we're able to offset that 500 megawatts. If we shut all those things off, SoCalGas packs up and leaves, that 2,000 megawatt plus a shortfall that we're facing next year is real. They predicted this year's one, and I'm pretty sure they were pretty darn close on next year's and the year after. 2,000 megawatts is something that I just don't see how they can offset it by shedding load. But we have very low fugitive emissions. I think the last count was less than 2% of our, that 100,000 miles of pipeline, we have less than 2%. Other states, especially in areas where it gets really cold, they have a lot more leakage in other parts of the country in their systems. Fugitive emissions is something we're constantly working on. We're spending billions of dollars in terms of rehabbing our gas distribution and transmission systems. I think we're spending $9 billion over the next few years to upgrade those. Like I said, we own the freeway. We don't care what color the cars are. And right now the cars are, fossil based. I'm hopeful that, we can convert peanut butter down the road and make a reliable fuel out of that. I'm all in favor of that. We're fuel agnostic. We've rebranded 3 times in the 12 months I've been with the gas company, and we may be the cleanest peanut butter mover, in the world in a year. We're moving gas. That's a now term solution. We're moving RNG. We're looking at hydrogen, and it may hopefully be something better down the road. We'll have the freeway ready to go to move whatever fuel meets those other conditions in terms of reliability. And it's going to be an exciting time. I can't think of a better time to be in the energy business than today. And for engineers looking for a future, I can't think of a more fun place to be than working for a utility.
Joe, really appreciate you kind of sharing with us today. I'm looking forward to the case this morning. We've got so many people on the line. I'm going to add one more question for you.
All right.
Because I think they're going to love hearing from you. You spent a career in energy, and of course you spent time at LEWP. I was on the phone with Craig Transby, and he says hi.
Yeah.
And yeah.
Hey, Craig, good guy.
And so there is a push for electrification, both of vehicles and buildings, within many utilities, whether it's up in Sacramento and with SMUD, but even Southern California Edison, which used to be there used to be the same utility at one point, and then of course LEWP. I wonder if you could talk about the relationship, because when we talk about transitioning an energy system, right? This is a system that's embedded in our society, right? And it's over, and so what is the working relationship between SoCalGas and Edison and SoCalGas and LEWP in trying to achieve these carbon goals, right, that we have, but also the reliability goals and the safety goals? And I know we only have, I want you to try to answer that in two minutes or so.
Oh, wow. Okay.
So that's the biggest challenge here.
I'll do that. Let me get there really quickly then. So I've been doing some research on our company, this new company I just joined, and we're the first utility in Los Angeles. Even before the Department of Water and Power, we were the very first utility there. 154 years ago in 1867, we were the gas lamp company that provided lighting in LA. I thought it was ironic that the reason our first existential threat to our existence was as a result of a guy named Thomas Edison, who brought electricity to Los Angeles. And so we had to pivot. We're having to pivot now, fast forward to 2021 in response again to Edison. I wish our relationship was better. I think there's a misunderstanding about electrification and our role relative to that. It doesn't happen without us. As you saw that banana, unless you only want power for 6 hours a day, you've got to have dispatchable generation. We're going to phase out coal. We're more than likely going to phase out nuclear. Those are thousands of megawatts of base load generation that run effectively 24/7. The reason why we have reliable, low-cost power in California is because we have a significant amount of resources of that type right now. Once those go away and they're being pushed, legislatively, they're a goner. You're going to have dispatchable power. Right now, it's gas. So I want to make this transition in a way that doesn't overburden folks who are already, fully challenged right now from an economic perspective. Let's not make utilities a luxury item in this state in terms of fairness, in terms of just morality. It's just something that the reason I came to the department or to the gas company is because I wanted to be part of the solution. I've been in those kitchens with some of the most humble homes I've ever seen in my life when I worked in the city of Los Angeles. So I want this to be a balanced approach that doesn't harm those families who I remember very distinctly. It's not fair. It's not right. If I fail, I will not miss a meal, but I can assure you I've seen families who will. So with that, I'll end.
Well, thanks again, Joe. I'm going to give folks here a chance to do virtual claps for you. Appreciate your time today.
I'm so blessed, really. Thank you, everyone, for letting me come on and take some time on a Friday morning with all of you. I hope you learned something, and I hope you Googled me to see if I was being truthful. I tried my best. But I really did appreciate this time. And Professor, I'm so thankful for this invitation this morning. I really am.